Good afternoon. My name is Nevyana and I am professor at Sofia University. Today, together with Theodor Doskolov from the same university, I am pleased to present our research entitled Modeling Consumer Responses to Water Scarcity Signals through Gamified Learning, an empirical study in the context of Industry 5.0. This study explores how consumers respond to water scarcity signals and whether these responses can be improved through gamified learning interventions. The research combines perspectives from scarcity theory, consumer behavior, gamification, and the human-centric approach of Industry 5.0. The central question of our study is whether developing consumer competencies through experiential learning can support more sustainable decisions under conditions of resource constraints. Water scarcity represents one of the most significant sustainability challenges worldwide. Although technological solutions and policy measures are important, individual consumer behavior remains a critical factor in achieving sustainable water management. Scarcity theory suggests that when people experience resource limitations, they may pay greater attention to the scarce resource and perceive it as more valuable. However, scarcity can also reduce cognitive capacity and encourage short-term decisions. This creates an important behavioral challenge. Consumers may react to scarcity signals through immediate compliance, but these reactions may not always lead to stable and sustainable consumption patterns. Therefore, our research investigates whether strengthening consumer competencies can help individuals interpret scarcity signals more effectively and make more sustainable choices. The theoretical foundation of our research combines two complementary perspectives. First, scarcity theory explains how individuals respond when they perceive limitations in available resources. Scarcity can increase the importance of a resource, but it can also narrow attention and encourage simplified decision-making strategies. Second, Industry 5.0 introduces a human-centric perspective that places center of technological and sustainability transformations. Based on this perspective, we argue that consumer responses to scarcity should not be viewed only as reactions to external pressure. Instead, sustainable behavior may depend on whether individuals have developed the competencies needed to evaluate trade-offs, anticipate consequences, and make informed decisions. The main objective of our study is to examine whether gamified learning can reshape consumer responses to water scarcity signals. Our conceptual model proposes that gamified learning does not influence sustainable behavior only directly. Instead, we suggest that its primary mechanism is competency development. Through learning activities, feedback, and repeated decision-making, consumers may improve their ability to evaluate consequences and choose sustainable alternatives. In addition, we examine the role of perceived scarcity pressure. While scarcity pressure may negatively influence sustainable behavior, we propose that higher competency can reduce this negative effect. Finally, we compare three different types of scarcity signals: price-based signals, restriction-based signals, and social norm-based signals. Based on the theoretical framework, we developed 6 hypotheses. The first hypothesis proposes that perceived scarcity pressure has a negative relationship with sustainable consumer behavior because strong pressure may lead to defensive or short-term reactions. The second hypothesis suggests that gamified learning contributes positively to competency development. The third hypothesis assumes that higher competency supports more sustainable choices. The fourth hypothesis examines whether competency acts as a mediator between gamification and sustainable behavior. The fifth hypothesis focuses on differences between scarcity cue types, assuming that consumers respond differently to economic, regulatory, and social signals. Finally, the sixth hypothesis proposes that competency can reduce the negative behavioral consequences of perceived scarcity pressure. To test our research model, we conducted a controlled experimental study with 240 adult consumers. Participants were randomly assigned to 2 groups. The control group completed water consumption scenarios without prior intervention. The experimental group first participated in a structured gamified learning model and then completed the same decision task. The experimental procedure consisted of 4 main stages: assessment of initial competency, exposure to the gamified intervention, completion of scarcity-based decision scenarios, and post-intervention competency measurement. The decision tasks included different scarcity signals: increased prices, usage restrictions, and social norm messages. For data analysis, we applied several methods, including analysis of variance, structural equation modeling, and mediation analysis in order to examine both direct and indirect relationships among variables. The gamified learning intervention was designed as a repeated learning cycle rather than simply an engagement activity. Participants in the experimental group made decisions in simulated household water consumption situations. After each decision, they received feedback about the environmental consequences and the impact on their choices on water resources. This process created a continuous learning loop consisting of decision-making, feedback, reflection, and a new decision under changed conditions. The purpose of this approach was to transform sustainability information into practical decision experience. In our study, gamification was therefore considered not only as a motivational tool, but as a mechanism for developing competencies. We measured several key constructs, including sustainable behavior choices, competency development, environmental awareness, and perceived scarcity pressure. The Sustainable Choice Index was calculated based on the proportion of water-saving alternatives selected by participants during the decision task. The results demonstrate clear differences between the control and experimental groups. While all the time we were thinking of how to measure the change, the Sustainable Choice Index increased from 0.53 in the control group to 0.71 in the experimental group. A similar pattern was observed for competency development. The post-intervention competency score was 3.85 in the experimental group compared with 3.12 in the control group. These findings indicate that gamified learning successfully improved participants' ability to evaluate sustainability-related decisions. Importantly, the results suggest that the intervention influenced behavior not only by increasing awareness but by developing decision-oriented competencies. Structural equation modeling was used to examine the relationships between the main theoretical constructs. The results confirmed several important relationships. First, perceived scarcity pressure had negative effect on sustainable behavior with coefficient of minus 0.28. This indicates that stronger feelings of scarcity pressure may reduce the likelihood of sustainable choices. Second, gamified learning demonstrated a strong positive effect on competency development with coefficient of 0.64. Furthermore, competency development had a strong positive relationship with sustainable behavior with a coefficient of 0.52. The mediation analysis showed that the indirect effect of gamification through competency development was significant. This means that gamification influences sustainable behavior mainly by strengthening consumers' ability to evaluate decisions rather than acting only as a direct behavioral trigger. An additional objective of the study was to examine whether different types of scarcity signals produce different behavioral outcomes. The results showed that scarcity signals are not equivalent. Social norm-based signals generated the highest level of sustainable compliance. Restriction-based signals produce an intermediate effect, while price-based signals had the lowest behavioral impact. The overall compliance score were 0.69 for social norm-based signals, 0.62 for restriction-based signals, and 0.55 for price-based signals. These findings suggest that consumers may respond more positively to messages emphasizing collective responsibilities and shared behavior than to signals based mainly on economic pressure. Therefore, sustainability interventions should consider not only whether scarcity information is communicated, but also how it is framed. The findings contribute to both theory and practice. From theoretical perspective, the study extends scarcity theory by introducing competency development as an important mechanism between external resource pressure and consumer behavior. Scarcity alone does not determine how consumers act. Their response also giving us the knowledge of how it looks from practical perspective. The results suggest that sustainability campaigns should move beyond providing information or applying restrictions. Building consumer capabilities through experiential learning may create more consistent and meaningful behavioral change. Educational and policy interventions can therefore benefit from approaches that help individuals understand trade-offs and develop sustainable decision-making skills. In conclusion, the study demonstrates that sustainable consumer behavior under conditions of water scarcity depends not only on external signals but also on internal capabilities. Our findings show that gamified learning can strengthen consumer competencies and support more sustainable choices. The results also highlight that scarcity signals should be carefully designed. Social and educational approaches may achieve stronger behavioral outcomes than purely economic pressure. Several limitations should be acknowledged. The study used simulated consumption scenarios, and future research should examine whether these effects remain stable in real-world environments. Further studies should also include longitudinal designs and more diverse populations to test the long-term impact of competency development. Overall, our research suggests that sustainability transitions require not only information and regulation, but also the development of human capabilities. Thank you for your attention. Have a very nice day.